so important when I don't start at the beginning of class to remind me about that. So Niels Bohr proposed that there were energy levels or shells. Do those terms sound familiar vaguely? Okay, and the electrons can inhabit those energy levels, okay? According to the Bohr model, there is a limited number of electrons allowed in each level, okay? Energy level 1, which I'm going to let you know, if you need to label it, you would label it N equals 1. N for energy level. Energy level, get it? Haha. Okay. So at energy level equals 1, you can have a maximum of 2 electrons. At energy level equals 2, you can have a maximum of 8 electrons. At energy level 3, you can have a maximum of 8 electrons. And at energy level 4, the Bohr model breaks down. So once you have put 2 electrons into energy level 4, we will simply never ask you to draw a Bohr model past that, okay? So it only goes up to element number, Bohr models only work up to element number 20, which is calcium. So Bohr models and that's element number 20. It just does not represent atoms well after that point, okay? So we're not going to bother with it. Do you remember the name of the outermost shell, the one on the outside? That is the valence shell. And so we call the electrons in the valence shell, what do we call them? Valence electrons. Imagine that. Now, here's the little tricky bit. And this is why it's in italics. Electrons in a partially filled valence shell. Partially filled valence shell are called valence electrons. The difference being that if the valence shell is completely filled, there are said to be no valence electrons. The reason for that is that valence electrons are electrons that can be involved in bonding. If you have a full electron shell, like a noble gas, do you have any desire to bond with any other atoms? No, you don't. And so you don't actually have any valence electrons because the valence electrons are the ones involved in bonding, okay? So let's put that down. These are involved in bonding. So if you have a completely filled valence shell, there are no valence electrons. That would be like a noble gas. So even though there are 8 electrons in the outermost shell, how many valence electrons are there? 0. Helium, a noble gas, has 2 electrons in its outer shell. How many valence electrons does it have? 0. Neon has 8 electrons in its outermost shell. How many valence electrons does it have? 0. All the noble gases have 0 valence electrons. So all, that looks like AM, Make it look like all noble gases have 0 valence electrons. A couple words that are probably new to you, but I'll wait until you're finished writing. Valence shells, which are partially filled, are called open shells. If a valence shell is completely filled, it's no longer open, it is closed. So what's the letter that we use to represent energy level? N. What do we call the outer shell? Valence shell. What do we call the electrons in the outer shell? Valence electrons. And what do we call a partially filled outer shell? Open. What do we call a completely filled one? Closed. All right, let's take a look at our first 20 elements. Okay, first of all, let's take a look, and do you remember what a period is in the periodic table? A period is a row. It goes this way. Okay, so this right here, hydrogen and helium, okay, those two, they are in row number 1. So they are in period number 1. It's kind of a funny row because it gets split, yes? You've got hydrogen, and then you've got gap, helium. Yes, that's period number 1. Period number 2, you've got lithium, beryllium, and then you'll notice we skip over that gap. Again, we've got a gap here. We've got lithium, beryllium, gap, boron, carbon, blah, 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 blah. Yes, that's period 2. Then we have period 3 is row number 3. And then we have period 4. That's what we call the rows or periods. What do we call the columns? Columns are called groups. Okay, so groups, a group is a column. So you'll notice we have group 1, group 2 on here, and then we're skipping over all the transition elements because you can't really draw Bohr models for transition elements, okay? So that's why we don't have them on this diagram, is because this is Bohr models, all right? Transition elements do not do well with Bohr models. Do you remember what group 1 is called, what the name of group 1 is? Group 1 is the alkali metals, except hydrogen is an exception. It's just its own little funny thing. Okay, so group 1 is the alkali metals, but not hydrogen. Hydrogen is its own group, okay? Hydrogen is a group of one. There's nobody else in hydrogen's group because there's nobody else quite like it. Do you remember group 2's name? Alkaline earth metals. That's group 2. So we have alkali, and then we have alkaline. There are 2 more groups that have names that we should know. Do you know which ones they are? The halogens, which is group number 17. So we have our halogens. I call them halogens, but either way is okay. Halogens and the noble gases is group 18. I'd like you to take a look at the number of occupied shells in period 1. Number of occupied shells in period 1. How many shells are occupied in period 1? 1 shell is occupied. And by the time we get to the end of period 1, what have we done to that shell? We've filled it up, we've closed it. Yes? Now, when we get to period number 2, how many occupied shells do we have? 2 occupied shells. Isn't that amazing? Okay, so this is why the periodic table is designed the way it is, and we spend period 2 filling up with 1, 2, 3, 4, 5, 6, 7, 8, and now our second shell is closed. It is full. Then we go, how many occupied shells in row 3, period 3? 3, and we fill that on up. And then period 4, we start filling it up, and then Bohr model falls apart, and we'll talk more about that later, okay? So we're not going to worry about that just yet. So that's what's happening in the periods. What do you notice when we go through group 1? What does all of group 1 have in common? 1 valence electron. What does all group 2 have in common? 2 valence electrons. And then it's too bad it wasn't group 3, but it is group 13. Okay, so we have a 3 there still. Group 13 has 3 valence electrons. Group 14 has 4, 15, 16, 17, 18, 0, because it's closed, it's full. So it has 0 electrons, 0 valence electrons, okay? All right. Now, when you are actually drawing a Bohr model, should you be called upon to draw such a thing, to be honest, I probably won't even have you draw one on a test because we'll be past it by that time. Okay. You can think of an atom as though it was a hotel. Okay. And in that hotel, there are various rooms. On the first floor, how many rooms do we have on that first floor? 1 room. How many rooms on the second floor? 4 rooms. 1, 2, 3, 4. And on the third floor, 4 rooms. Each room can accommodate 2 electrons. So we have each room can accommodate 2 electrons maximum. All right. Now let's imagine you're arriving at this hotel, and this hotel has no elevators. Where would you like to go first? And you've got lots of luggage with you. Where would you like to be staying? Closer to the bottom, right? Because there's no porters. You have to carry your own luggage. So you're like, okay. So electron number 1 is going to go, and I'm sorry, that doesn't look very nice, but electron number 1 is going to go in that first shell. Electron number 2 is going to go here, so 1 and then 2. That's not 12. 1, comma, 2. Okay. I should have made it much lighter. And then on the second floor, now let's imagine that you're checking into this hotel. The first floor is full, so where will you check in? Second floor. So electron number 3 is going to go here. I always start at the top. It really doesn't matter where you start. I just always start at the top and go clockwise so I don't have to think about it very hard. But the trick is that if you were an electron and you didn't know any of the other electrons, would you want to check into the same room as someone else, or would you rather check into your own room? You would rather check into your own room, yes? Okay, so where will electron 4 go? In a different room, okay? It could go here or here or here. Like I said, it doesn't matter. I'm going to put number 4 here because I like to go around, like I said, like a clock, okay? Where is number 5 going to go? At the bottom. And then 6 will go here. Now, even though it's a little weird to check into a room with someone you don't know, let's pretend it's like a hostel. You're backpacking around Asia or something like that. You know, sharing a room's not so bad. It's certainly much better than packing your luggage up to the 3rd floor. So you will now, if you're electron number 7, where will you go? You'll go here. Okay, so once each room has 1 electron in it, then they will pair up. Okay, but not until there's a single electron in each room. Yes? So 7, 8, 9, 10, and then you would do the same thing. You would have 11, 12, 13, 14, 15, 16, 17, 18. And then if you do have to do a 4th shell, remember we're not going to have, I'm not going to draw the whole thing because I'll make an absolute mess of it. You can see how good my circle is looking to start with. You would have a room here and a room here, and you would have various other rooms, but we're going to ignore those because remember, the model breaks down after that. Yes? So there's like, technically you could kind of say there's 18, but it's so inaccurate that we don't bother, right? And nobody wants to draw that many electrons anyway. Anyone want to draw 18 electrons? No. Okay, so we're going to stick with the fact that if we have a 19th electron, it will go here. And if we have a 20th, it will go here. And then after that, we're just going to pretend that Bohr models don't exist anymore, okay? The rest of the hotel, I don't know. There was an earthquake, fell down. It's on the ground now. I don't know. Anyway. Okay, let's just not go there. So let's just leave that alone. Okay. So that is how you fill in a Bohr model. So for example, here we have oxygen. And we would say oxygen is atomic number 8. What does that tell you? What does the atomic number tell you? It tells you the number of protons. And normally atoms are, what charge are atoms? Atoms are neutral, which means their charge is 0. If you have 8 protons, 8 positive things, how many negative things must you have? You must have 8. Oh, it's such a relief. I say that in my grade 9 class, and there's a few people who really struggle with math. And it's like, 2? Like, and you know that obviously, like, this is just not penetrating at all, right? And so you have to start drawing things, right? And I feel so bad for them because I'm like, this must, like, life must be so hard for you. Because, like, yeah. Anyway, hopefully all of you can see that if we have 8 positives, we must have 8 negatives in order for the overall charge to be 0. So we would start filling in our electrons. We would go 1, 2, 3, and then go around the clock. 4, 5, 6, 7, 8. All right. How many valence electrons does oxygen have? 1, 2, 3, 4, 5, 6. 6 valence electrons. Yes? So what group is oxygen in? Oh, no, you don't need to look. It has 6 valence electrons. Therefore, it is group 16. 16. Okay? What do you remember about shells and how they like to be? They love to be full. Shells love to be full. Now, when I say love, do electrons really have feelings? No. Okay? Electrons do not have feelings. They're not like, oh, look at that shell, it's empty. I just want to go in there. They're not like that. They're like, ooh, lovely decor. I'm going to check into that hotel. No. Okay? But we do have here 2 gaps. Yes? So if we were going to form an ion, what would have to happen to this structure to become full? So this would be, you would add 2 electrons, yes? And if you add 2 electrons, what is your overall charge? -2. So your symbol would be O2 minus. That's if we did the ion. I'm just sort of adding this in down below. So this is the ion bit. We're not really talking about ions yet, but I'm just giving you a little preview here. Okay. So we're just going to leave this. This is an oxygen atom, and it is neutral because all atoms are neutral. If we were forming an ion, though, it would gain 2 electrons and it would become -2. Okay. So here's some practice. We could do that. We're not going to do that. You can do that at home. Okay. The only thing to remember is that in your nucleus, we have sodium 24. So in our nucleus, sodium is atomic number 11. So how many protons? So we would have 11 protons. It is sodium 24. What is that number there? That's the mass number. What's it equal to? Protons and neutrons together. So how do we find the number of neutrons? It's going to be 24 minus 11. It's the mass number minus the protons. If you forget that, where could you look? You could look back at the beginning of your book. I think it's probably about here. 3.0c. So if you're like, I don't remember how to find the number of neutrons, oh no, but on page 3, it tells you. Okay, so you can go back there and look if you've forgotten. Alrighty? Okay. Where are we at? Here we are. Okay. So now we have 13 neutrons. So in our nucleus, we will put 13 neutrons. And it is a neutral atom, so if it has 11 protons, it must have how many electrons? 11 electrons, and you'll notice we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay? So you can practice those ones on your own over the weekends. No, why is it sideways? Oh. Okay, hold on. No, okay, hold on. How much time do we have? We have enough time for me to print this again, don't we? Yes, we do. That's page 40. Okay, here we go. Let's find page 40. Where'd it go? Oh, why is this sideways? I'm so confused, but that's okay. File, print. Page, current page. Print. Lordy. Okay. Okay. Whew. Okay. When drawing the Bohr model of an ion, basically what you have to do is you have to look at your atom I feel like there's a handout that I left out of here that would have been helpful to you, but I don't know why I didn't put it in. I was like, you guys are in grade 11, you know this already. So let's say we had, I know. I'm just gonna actually do this by hand. So let's say we had, I don't wanna do calcium, let's do something smaller. Let's do lithium. How many protons in lithium? 3. If it is lithium, how many neutrons? 5. Okay, so in our middle, we're going to have protons equals 3, neutrons equals 5. And if this is I recommend that when you are drawing the ions, you draw the atom first and then turn it into an ion. So draw the atom first, then turn it into an ion. Okay? So what am I going to draw if I'm drawing the lithium atom, which is neutral? I'm going to draw my first shell, and how many electrons will I put in my first shell? 2. 1, 2. And then I have a third electron, and I put it here. And then I say to myself, is it easier to fill or easier to empty? And the answer to that is anytime you have 5 or more valence electrons, it's going to be easier to fill, right? Because you're closer to 8. Anytime you have 3 or less valence electrons, it's going to be easier to empty because you're closer to empty than to 8. Yes? 4 doesn't actually form ions, they form covalent bonds only. They share. Okay, so 4, we don't worry about forming ions because they just don't do that. Okay? So, we are close to empty here, yes? So this electron is going to go bye-bye. Bye-bye. All right, off it goes. We have emptied the shell. And in emptying the shell, we lost 1 electron. If you lose something that has a -1 charge, what is your charge? +1. So we're going to put square brackets around this whole thing so that we're saying this whole thing has a charge. And on the outside of those brackets, we're going to put a plus. Because in chemistry, we don't usually write +1, we just write plus to mean +1, okay? So we have gone from having a lithium atom to having a lithium ion. It still has 3 protons. What would happen if I changed the number of protons? It would change the element. I wouldn't have lithium anymore. We're not going to do that, okay? We're not doing nuclear reactions. Because we're just not, we have enough to learn this year. And we can't do any in the classroom anyway. I'm sorry. No nuclear bombs for you, young man. None. Okay. So what number is going to go up top on the lithium? 8, because remember that is the mass number, that is the protons plus neutrons. This number down here, that's the atomic number, that's the protons. What if we had nitrogen? Nitrogen 15. Okay. How many protons? Not 15 protons, because remember, this is the protons plus neutrons. 7. Okay, it's atomic number 7. How many neutrons? 8. Okay, so now we have 7 protons, we have 8 neutrons. That's going to go where in our Bohr model? In the nucleus. So we have protons equals 7, neutrons equals 8. How many electrons will we have if we have a neutral atom? We will have 7. So we're going to start by drawing all 7. Because always start by drawing the that too, but always start by drawing the neutral atom. Change it to an ion later. What should you start with? The neutral atom. What should you start with? 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 Everyone over here. No! God. Oh. Okay. Start with the neutral atom and then transform it into an ion. Then change to an ion by adding or subtracting electrons. So we're going to start with 7 electrons. 1, 2. That's full. 3. Where does 4 go? Does 4 go here? No. Where does 4 go? Yeah. 4, 5, 6, 7. Is this atom going to gain or lose? So that's 5. So are we closer to full or closer to empty? Closer to full. So we are going to, how many? 3. electrons. So I'm going to put them in. I'm going to make them a different color, 1, 2, 3, so I can see them. It is an ion, and an ion Bohr model, what does it need? It needs brackets and it needs a charge. So we're going to do big square brackets. If we gained 3 electrons, what's the charge? 3 negative. Okay. Let's see if we have enough to send you home. La la la. Huh? Uh-huh. Uh-huh. Oh, I know. No, we already did this. We know what kind of an ion is that? It's negative. What's it called? It's an anion. And what is our positive ion there? That is a cation. Excellent. And then and then I'd like you to do pages 34, 35, 39 and 40. Now, if you're like, okay, that sounds like a lot, Miss Spence, do every second question. Do you know what I mean? If it's too much, do every second question. So if you have a lot on this weekend, you know, you've got some event that you need to go to, do every second question. If you've got the time, do them all right? And look, we're done 5 minutes early, or almost 5 minutes.